Every day we walk on solid ground, confident that we know our world. But what if I told you that beneath your feet lies an unseen universe, darker than night, older than mountains, and teeming with life we never imagined could exist? This is not science fiction. It is the hidden reality beneath the Earth's crust, a world that challenges everything we thought we knew about what it means to be alive. Imagine standing on a patch of solid ground, feeling the firmness beneath your feet, believing that what you see around you is all that matters: the soil, the rocks, the mountains, and the oceans. For most of us, the Earth is defined by what lies at the surface: the rivers that carve through valleys, the forests that teem with life, and the bustling cities we build. Yet beneath this familiar landscape lies a realm that is almost entirely hidden from our senses, a place we rarely think about, though it is as vast as it is mysterious. This unseen world beneath the Earth's crust is not just empty rock and molten material. It is a domain where life, processes, and extraordinary adaptations exist in ways that challenge our imagination. To begin exploring this world, it helps to picture the Earth as more than a surface we walk upon. Think of it instead as a layered sphere, with its outer crust like the thin skin of an apple. That skin, surprisingly, is all that separates us from the deeper parts of our planet. It is delicate in comparison to the layers below, and within it, cracks, cavities, and hidden channels create an intricate network that life has found a way to inhabit. This realization that beneath our everyday landscapes lies an unseen and largely unexplored environment invites us to look downward, not just outward, when we think about life. What makes this hidden world even more fascinating is that it operates beyond our normal frame of reference. We are used to life depending on sunlight, plants, and oxygen in the air. But beneath the crust, sunlight cannot reach. Darkness is absolute. Temperatures can soar to unbearable extremes in some places or sink to freezing depths in others. Pressure builds to levels that would crush us instantly. To us, it may appear completely inhospitable, and yet life is there. Tiny, resilient organisms have adapted to survive in this unforgiving environment, feeding on chemical reactions, minerals, and even the energy released from the interaction of water with rocks. They do not need what we call the essentials of life on the surface. Instead, they redefine what it means to live. For centuries, this subsurface world was thought to be lifeless, an empty stone barrier between us and the Earth's fiery mantle. But discoveries made in the last few decades have upended that belief. Scientists have drilled miles deep into the crust and found thriving colonies of microbes. They have entered caves where light has never penetrated and encountered ecosystems completely isolated from the surface. These findings suggest that the hidden biosphere beneath us is not just an oddity. It is enormous, possibly containing more biomass than all the oceans and forests combined. If true, it means the majority of Earth's life is not visible to us, but rather buried deep within the crust, quietly existing, shaping the planet's chemistry and influencing the world above. Reflecting on this, one can't help but feel a sense of humility. We often see ourselves as explorers of the stars, reaching outward to find new planets, new galaxies, and the possibility of life beyond Earth. Yet in many ways, the greatest frontier lies directly beneath our feet, in a world we have barely begun to understand. What lives beneath the Earth's crust forces us to rethink the boundaries of the possible. It expands our perspective on where life can exist and how it adapts in environments we once dismissed as barren. So when we begin this journey of discovery, starting from the crust and moving deeper, let us remember that what lies below is not simply rock and molten layers. It is a hidden universe that tells us life is more resilient, more adaptable, and more extraordinary than we ever imagined. And it is here, beneath the very ground we take for granted, that some of the most profound secrets of existence quietly reside. That is where our exploration begins. Beneath the ground we walk on lies more than a dark and hidden void. It is structured, layered, and alive with immense forces that shape our planet and sustain its balance. To understand what truly lives beneath the Earth's crust, we first need to know what lies beneath us in terms of structure. Because this framework provides the environment in which life, energy, and geological processes operate. The Earth, though it feels solid and immovable, is in fact a dynamic sphere made up of distinct layers. The very top is the crust, a thin, brittle shell like the skin of an apple compared to the vastness beneath. This crust, only a few miles thick under oceans and up to about 40 miles thick under continents, is the surface we inhabit. It is broken into tectonic plates that slowly shift and collide, building mountains, opening rifts, and generating earthquakes. This crust is our immediate home, but it is only the beginning of what lies beneath. Beneath the crust is the mantle, a layer so vast it makes up most of the planet's volume. Unlike the rigid crust, the mantle is a slow-flowing solid, a zone where rocks can move and deform over geological time. Convection currents churn here, rising heat from the depths of the planet and driving the motion of the tectonic plates above. This movement is not only the reason continents drift and oceans widen. It also sets the stage for life by recycling essential elements from deep within the Earth to the surface. Without the mantle's restless churning, the surface of our world would be static, lifeless, and barren. Below the mantle lies the outer core, a sea of molten iron and nickel, swirling with such intensity that it generates the magnetic field surrounding our planet. This invisible shield protects us from harmful solar radiation and cosmic particles, making life on the surface possible in the first place. Deeper still is the inner core, a solid ball of iron and nickel hotter than the surface of the sun, compressed into solidity by staggering pressure. We cannot reach it, we may never touch it, but its existence holds our planet together and keeps its systems running. What is important to realize about this structure is not just its geology, but its profound connection to life. The crust provides the immediate environment for microbes, cave systems, and larger subterranean species. The mantle's interactions with water and rock create chemical energy that fuels underground ecosystems where sunlight never shines. Even the core, through its magnetic field, shields Earth's biosphere from destruction. Life beneath the crust is not isolated from these layers. It is deeply intertwined with the dynamic processes that shape them. So when we ask what lives beneath, we must first appreciate where it lives. The delicate crust riddled with fractures, the mantle that provides heat and chemistry, the deep movements that allow life on the surface to flourish. Beneath our feet, there is no simple empty space. There is a planet alive with motion, chemistry, and structure, all of which provide the canvas for extraordinary forms of hidden life. And it is in this layered foundation that we can begin to see how survival in darkness, pressure, and heat becomes possible. That is the stage on which the deep biosphere begins to emerge. Deep beneath the surface, far away from sunlight and the air we breathe, scientists have discovered an entire hidden biosphere, an underground world dominated not by plants or animals, but by microorganisms. And yet, deep below our feet, countless microorganisms have developed survival strategies that stretch our understanding of biology. They are masters of endurance, finding ways to extract energy from sources we would never imagine, persisting in environments that would be instantly lethal to us. On the surface, nearly every ecosystem depends in some way on the sun. Plants capture sunlight, animals feed on plants, and the chain continues. But underground, in complete and permanent darkness, sunlight does not matter at all. Life here depends instead on what we call chemosynthesis. Rather than harnessing light, microbes use chemical reactions to fuel themselves. When water seeps down through cracks in the crust and meets certain types of rock, it sets off a chain of reactions that release hydrogen gas, methane, and other compounds. To us, these gases are insignificant, but to deep microbes, they are food. By breaking down these substances, they generate energy in the same way plants convert sunlight into sugars. Other organisms specialize in consuming sulfur, iron, or even radioactive decay products found in the surrounding rocks. In some cases, microbes tap into minerals in the stone itself, drawing sustenance from what appears to be solid, lifeless material. This incredible adaptability reveals just how resourceful life can be. It also tells us that survival does not require abundance, it requires ingenuity. These microbes make do with what little is available, carving out existence molecule by molecule, atom by atom. Another astonishing survival strategy is their patience. Life underground often moves at a pace we can hardly comprehend. Some microbes grow so slowly that their life cycles stretch across centuries. In nutrient-starved environments, they conserve energy by entering near-dormant states, dividing perhaps once every 1,000 years. To us, such timescales seem impossible, but underground, where stability lasts for millions of years, this slow-motion way of living works perfectly. Survival here is not about speed but endurance. Then there is the matter of pressure and temperature. Deep beneath the crust, pressure rises to crushing levels thousands of times greater than at the surface. Yet microbes flourish even under these conditions, their cellular structures adapted to resist collapse. Temperatures, too, range from icy cold in deep aquifers to searing heat near hydrothermal vents or magma intrusion. Some organisms, known as extremophiles, are specifically adapted to thrive in these extremes, surviving in conditions that would obliterate most surface life. These survival strategies are more than biological curiosities. They are windows into possibility. They show us that life is not fragile but resilient. It can survive without sunlight, without oxygen, without conventional food. It can persist in crushing darkness and fiery heat in seemingly impossible conditions. And perhaps most importantly, these strategies reveal a truth that extends far beyond our own planet. If life can adapt here in the hidden cracks and stones beneath Earth's crust, then life could adapt elsewhere too, in other worlds where sunlight is scarce but chemistry is abundant. The deep organisms beneath our feet do not just survive. They thrive in ways that completely rewrite our assumptions about what life requires. And as we uncover these strategies, we begin to see that the limits of life are far wider and far stranger than we once believed. When we think about the role of life on Earth, most of us imagine forests producing oxygen, oceans storing carbon, or surface ecosystems keeping the planet in balance. But beneath the crust, in the hidden biosphere, microbes are playing their own quiet yet essential part in maintaining Earth's stability. They may be invisible, but their influence stretches across planetary systems. These organisms are not just passengers buried deep in rock. They are active agents, cycling elements, shaping chemistry, and in many ways sustaining the very conditions that allow life above ground to flourish. One of the most important roles of subterranean life is recycling. In the deep crust, microbes continuously break down and rebuild molecules, participating in elemental cycles just as plants and animals do at the surface. For example, carbon, which is central to all life, is not simply stored in fossil fuels or dissolved in oceans. Deep microbes consume and release carbon compounds, helping regulate how this element moves through the earth. Some take in carbon dioxide, locking it into minerals or organic matter, while others release methane, a process that connects the underground biosphere directly to the atmosphere. Even though these exchanges happen slowly, their cumulative effect over millions of years is profound. Nitrogen, too, is cycled underground. Microbes beneath the crust transform nitrogen compounds into forms usable by other organisms, completing a process that eventually connects to soils and ecosystems at the surface. Sulfur and iron are also part of this hidden economy. Entire microbial communities thrive by shifting these elements back and forth between chemical states, influencing the composition of groundwater, the chemistry of rocks, and even the formation of valuable mineral deposits. Without these deep chemical transactions, Earth's cycles would be incomplete, less stable, and far less supportive of life as we know it. Another critical role deep life plays is in buffering the planet against extreme. By consuming gases like methane or hydrogen sulfide, microbes act as natural regulators, preventing these compounds from building up unchecked. In some cases, they help stabilize underground environments by controlling acidity or neutralizing reactive chemicals. In others, they form biofilms, thin layers of microbial communities that coat rock surfaces, protecting ecosystems and slowing chemical erosion. These subtle actions, repeated across countless miles beneath the crust, create a kind of planetary balance that operates far beyond our awareness. It's also important to recognize how connected the underground biosphere is to surface life. Though isolated in deep fractures and aquifers, microbial activity beneath the crust eventually links back to rivers, oceans, soils, and even the air we breathe. The water that resurfaces through springs, the gases that seep upward through cracks, and the minerals carried into soil are all influenced by microbial work done far below. In this way, deep life becomes part of the grand interconnected system that makes Earth habitable. What makes all of this even more remarkable is the scale. Studies suggest that the deep biosphere could contain a vast majority of Earth's microbial life, perhaps even outweighing all animals and plants combined. If true, then these roles, recycling, regulating, connecting, are not minor but central. They suggest that much of the stability of our planet comes not from what we see, but from the invisible labor happening out of sight. So when we ask why the deep biosphere matters, the answer is clear. It is not simply a curiosity or a hidden oddity. It is a critical part of Earth's living system, silently working to keep balance, stability, and continuity across the ages. The life beneath the crust is, in many ways, the unseen foundation upon which all surface ecosystems depend. And in recognizing its role, we realize that the story of life on Earth is not just written above. It is also written deep below, where microbes keep the heartbeat of the planet steady. When we imagine what lives beneath the Earth's crust, our minds often leap to the invisible, the microbes hidden in rock pores and the strange chemotrophs feeding on minerals. Yet the underground world is not entirely microscopic. In the cracks, caves, and tunnels that wind beneath the surface, larger organisms have also carved out their existence, adapting in extraordinary ways to a life without sunlight. These creatures remind us that survival in the subterranean realm is not limited to the unseen. It extends to a whole community of animals that have evolved to thrive in darkness. Caves, perhaps the most familiar window into the underground, are home to an astonishing variety of life. Within these shadowed spaces live insects, arachnids, crustaceans, amphibians, and even fish, all shaped by generations in an environment of perpetual night. Deprived of light, many species have abandoned eyes altogether. Blind cavefish, for example, navigate by touch and vibration, relying on finely tuned senses to detect water movement. Similarly, cave insects often lose pigmentation, their bodies turning pale or translucent, as color serves no purpose in the dark. These physical changes are not signs of weakness, but remarkable examples of adaptation, proof that life reshapes itself to match its environment. Food, however, is the greatest challenge underground. Without sunlight, there are no plants to serve as the base of the food chain. Instead, most cave ecosystems depend on materials carried in from the surface. Bats, for instance, are crucial contributors. Their droppings, known as guano, provide a nutrient-rich foundation that supports entire cave communities of insects, fungi, and smaller animals. In water-filled caves, organic matter from rivers or surface runoff sustains blind shrimp, salamanders, and other aquatic life. Even here, in such scarce conditions, ecosystems form and sustain themselves, showing once again that life can persist wherever it finds even the faintest foothold. Beyond caves, the soil itself teems with creatures adapted to hidden living. Worms, beetles, and termites create networks of burrows aerating the ground and recycling nutrients. While they do not live as deep as the microbial biosphere, their contributions are vital, linking surface ecosystems with the underground world. Some animals, such as moles and naked mole rats, spend nearly their entire lives underground, perfectly suited to the cramped spaces, low oxygen, and constant darkness. In every case, these species reflect the same lesson. Survival below the crust demands specialization, and life is capable of meeting that demand in astonishingly diverse ways. Even at greater depths, in places that seem wholly cut off, researchers occasionally discover new species. Small crustaceans in deep aquifers, worms in isolated pockets of water, organisms surviving in spaces once thought barren. Each discovery expands our understanding of what is possible and hints at how little we have truly explored. The underground is not an empty void, but a frontier of life, populated by forms both familiar and alien, quietly adapting to their hidden realm. What these larger subterranean creatures reveal is a continuation of the same story told by microbes. Life finds a way. Whether it is an eyeless fish swimming in total darkness, a colony of bats feeding entire ecosystems with their waste, or tiny insects navigating by touch instead of sight, the underground world demonstrates resilience and adaptability on every scale. It reminds us that beneath our feet lies not just geology, but living, breathing ecosystems, silent, unseen, but profoundly important. And together with the microbial communities deeper still, they weave a picture of a planet that is alive not just on its surface, but through its very depths. To truly understand what lives beneath the Earth's crust, we also have to consider how we know what we know. The deep biosphere is invisible to the naked eye, locked away in rocks, fissures, and caves miles below the surface. Discovering it has required not only curiosity, but also some of the most advanced scientific tools and methods humanity has ever developed. Without exploration and technology, this hidden world would remain sealed off, a mystery buried in stone. One of the most direct ways scientists investigate life underground is through drilling. Across the world, research teams have bored deep into the Earth's crust, extracting samples of rock, water, and gas. In some cases, these boreholes extend thousands of meters down, bringing to the surface microbes that have lived in isolation for millions of years. Such drilling projects, whether for oil, geothermal energy, or pure science, have provided glimpses of organisms clinging to life in deep, pressurized environments. Every core sample becomes a time capsule, a window into the biosphere that exists far below our reach. Caves offer another natural gateway into the subterranean world. Explorers and biologists venture into caverns where no sunlight has ever reached, documenting ecosystems completely cut off from the surface. These environments often harbor unique species of fish, insects, and microorganisms, many of which exist nowhere else on Earth. Caves are living laboratories, providing both accessible entry points and stark reminders of how strange and diverse underground life can be. Beyond drilling and caving, technology allows scientists to probe even deeper. Seismic waves, for instance, help map the structure of the Earth's layers, revealing the fractures, cavities, and aquifers where life might dwell. In some locations, robotic probes and remote-operated submersibles explore flooded cave systems and underground lakes, capturing images and samples that human divers cannot reach. Advanced sensors measure heat, pressure, and chemical composition, helping researchers pinpoint environments where microbes are most likely to survive. Another powerful tool is molecular analysis. Even when scientists cannot isolate living organisms directly, they can study DNA and chemical traces left behind in rock and water samples. These genetic signatures reveal not only the presence of life, but also the types of organisms adapted to thrive in particular conditions. In some cases, scientists have identified entirely new branches of the microbial tree of life through DNA fragments alone, expanding our picture of biology in ways no microscope could achieve. Importantly, exploration is not limited to Earth itself. The technologies and methods used to search for life underground here are also being applied to the search for life beyond our planet. Drilling through ice sheets in Antarctica, studying hydrothermal vents at the bottom of oceans, and probing deep rock formations all mirror the strategies we may one day use on Mars or the icy moons of Jupiter and Saturn. In this sense, every discovery beneath the Earth's crust is also a rehearsal for the search for life in the wider universe. The act of exploring the subterranean biosphere is not just about cataloging strange organisms. It is about pushing the boundaries of human knowledge. It requires us to blend geology, biology, chemistry, and engineering into a single pursuit. And with each core sample, each cave dive, and each new genetic sequence, we peel back another layer of mystery, revealing that the Earth is far more alive, far more dynamic than we ever imagined. Through exploration and technology, the hidden world beneath the crust is slowly opening itself to us, and with every step, we come closer to understanding the full story of life on this planet. As we draw closer to the heart of this hidden world, it becomes clear that what lives beneath the Earth's crust is not simply a scientific curiosity. It is a key to understanding our future. The organisms thriving in darkness and pressure show us that life is far more resilient than we once believed. Their existence reshapes our view of what is possible, not just here on Earth, but across the cosmos. If microbes can endure without sunlight, feeding on stone and gas, then perhaps worlds like Mars, Europa, or Enceladus could harbor their own hidden biospheres. Studying Earth's deep life becomes, in this way, a guide for the search for extraterrestrial life. But the significance extends beyond astronomy. The deep biosphere also forces us to rethink the very boundaries of habitability on our own planet. These organisms cycle carbon, nitrogen, sulfur, and countless other elements, forming a hidden foundation that helps regulate Earth's chemistry. Understanding their role may one day help us address global challenges: climate change, carbon storage, and sustainable energy. Some of these microbes may even hold the key to biotechnological advances, providing enzymes capable of functioning under extreme heat and pressure, or novel ways to process waste and create clean fuel. The subterranean world is not just a curiosity. It is a resource, a library of solutions shaped by billions of years of adaptation. And there is also the philosophical weight of this discovery. For so long, we believed life was a fragile phenomenon clinging to a narrow band of conditions on the surface of a single planet. Yet beneath our feet, in places we once dismissed as sterile, life thrives in astonishing diversity. This realization humbles us. It tells us that life is not the exception, but the rule. That wherever there is energy, chemistry, and time, life will try to find a way. The deep biosphere becomes a mirror, reflecting back the truth that survival is not only possible in extremes, but often most extraordinary there. So as we step back and reflect on what we have uncovered, from the structure of the Earth itself, to the microbes in stone, to the blind fish of the caves, to the technologies that allow us to glimpse it all, we are left with a simple but profound lesson. The story of life is not written only in forests, oceans, or skies. It is written in the silent depths beneath the crust, in places we cannot see but must learn to understand. And it is there, in those depths, that we discover not only what lives beneath the Earth's crust, but what life itself truly means. So when we bring all these discoveries together, the structure beneath our feet, the microbes hidden in stone, the strange strategies of survival, the larger creatures in caves, the unseen cycles of chemistry, and the technologies that allow us to peer into this shadowed realm, we see that what lies beneath the Earth's crust is not emptiness but abundance. It is a world that teaches us resilience, a world that proves life is not fragile but unyielding, able to endure where nothing should. It is a reminder that the heartbeat of our planet is not only on the surface, where we walk and breathe, but also deep below, in the darkness, where unseen communities quietly sustain balance. And perhaps most importantly, it is a lesson for the future. That life is broader, stranger, and stronger than we once imagined, and that by looking downward, we may find the key to looking outward toward other worlds and other possibilities. The hidden life beneath the crust does not just expand our knowledge of Earth. It expands our imagination of life itself.